Okay, let us continue. And don't waste any time. So next up, we have Fabian, who will talk about cross-session activation attacks. Please welcome our speaker.
Okay, so hello everyone. I'm super happy to be here today and to give this talk. So the talk's named Revisiting Cross-Session Activation Attacks. Short introduction, who am I? My name is Fabian Mosch. I'm working for a company called Artec Cybersecurity in Germany. I'm the head of the pentest/red team there, and I like to break into company environments, to escalate privileges there, and to simulate an attacker. I'm also publishing scripts, tools on GitHub, doing blog posts, and did some YouTube videos with the handle Secure the Shit or Shit Secure. And I'm also the founder of a company called MSEC Operations, and this company was founded last year, and it's doing AV, EDR evasion tools for pen testers or for red teams. So what the heck am I talking about today? Cross-session activation attacks. Who of you has ever heard of this before? Just out of interest from me? Okay, there's 2 raising hands. I hope you will still understand it then, because I was at least digging a lot into this to get an overview and to understand it. If you Google this, you will find this documentation from Microsoft. But this documentation, what you find from Microsoft, is actually not what I'm going to talk about today. I also asked AI about cross-session activation. The results were super bad, so didn't even put this in here. So you will not find what I'm talking about if you just Google for it, because it's something different, and it's not really documented. But to understand this whole concept and these attacks, I need to at least talk a little bit about COM basics and what it's about. So in the first place, with COM, there's some classes are defined, and these classes are in the very end code, functionality, which is available by different applications, by different processes on a Windows operating system. So this can be shared functionality between different processes, for example, and this code is usually hosted inside of an DLL or inside of an executable on the Windows operating system, and can be used by other processes. If another process wants to use this functionality, they need to know about the unique identifier, which is the CLS-ID, so-called CLS-ID. And with this CLS-ID, they can say, okay, I want to use the code from this CLS-ID. They can call specific functions from this COM class, and they can use it. Usually, the COM objects are located in, or mainly in 2 different entries on the registry on the Windows operating system. So on the one hand side, it's the application identifiers, which are identified, located on the HK local machine. And here you can see that some specific entries are defined like for the protection and for what can be done. On the one hand side, you can see who has access permissions, who can actually invoke this class, who can use it, who has the permissions to launch it. And there is also an key which is called run as. And in this case, it's set as interactive user. And this interactive user is in the very end one of the prerequisites for this whole attack of cross-session activation attacks. So if an app ID is set to interactive user, then this can be potentially abused for this attack. So this means the COM class will be called, or the process will be called in the context of the user, which is currently logged on to this system. There is also reference to a service executable or to a DLL. These are usually found in a folder, in this CLS-ID folder. And there's usually the DLL is referenced there. So in this example, you see there is MB AE API.dll, and this is the DLL which hosts the code for the CLS-ID starting with 941. Exactly. There is also CLS-IDs under HKey current user, but under HKey current user, mostly you will not find the DLL. This will be important later on, but the main references can be found on a HK local machine. So cross-session activation, as I said, what you find on the Microsoft documentation, this is not what this talk is about. So the talk basis on a lot of tools and research which was published over the last years. And the first prerequisite is that the CLS ID needs to be configured as the interactive user so that we can use this attack. And now I'm going through some Windows APIs which usually are used when you're attacking this or when you're using this attack. So in the first place, you call co-create instance to create a COM object for this target class. Then we are using query interface, and we're querying the I special system properties from this interface pointer. And this is all documented till this point. So what is not documented anymore, and what was found, I think, by James Forshaw in the very first place, so the link is at the bottom. Now you can use this undocumented Windows API set session ID and set a different session ID on the special system properties field. So this, in the very end, leads to the fact that you can execute COM functionality in the context of another user which is also logged on the system or on a remote system. So not in the context of your own user, but in the context of another user. And usually this cannot be done with a low privilege user. Then there is, you need to use standard get instance from iStorage to actually trigger this attack. And in the very first tools that were published, and I'm going to show them later on, calling this API leads to the fact that an NTLM or Kerberos authentication is triggered in the context of the other user from the session ID which you specified, so that you get this hash and you could relay it, for example, or you could try to crack it to get the user's password. So this is the general concept of how all these tools work in the very end, in the back end. And as this is a complex topic, and if you don't fully understand it, I can only recommend you to go through these blog posts and to everything linked there, because it's explained much more in depth there. So what is the history? What was already published over the last years? So from my knowledge, the very first tool that abused this whole technique and which was published is Remote Potato. And Remote Potato allowed, so when you're logged on a system, so like a terminal server, for example, in a Windows environment, usually on a terminal server there's multiple users logged on, right? So you're logged in and there's also 5 other users on the same system. And if one of these users is an administrator, you could, as the local low-privileged user, trigger an authentication from the admin user and relay this authentication to, in the first place when it was published, to LDAP, to, for example, do some LDAP modifications to add yourself to the domain admins group, and so on and so on. So this was the first tool. Later, a little bit later, KRB relay was published. From the concept, it's very similar, but instead of relaying NTLM, this tool focuses on relaying incoming Kerberos authentication. So even if NTLM would be disabled, for example, this tool could be used to trigger Kerberos authentication and to relay to a remote system to LDAP, to go for LPE if you trigger an authentication from the local system account, or to relay to HTTP, or to relay to SMB. So there was a lot of options implemented in this tool so that you could choose on what to do with this other user's credentials and where to relay to. Yeah. Even later, and this was in 2024, 2 tools and 2 techniques were published which are in the very end the same, but this was research in parallel more or less from how I understood it, because it was published at Black Hat Asia and it was also published in the blog post where you can see on the bottom from Andrea Brieri. And the tools that were published are Certified DCOM and ADCS Chorus Potato. And these tools allowed you to trigger an authentication from a remote ADCS, so the PKI server, and to relay this incoming authentication to LDAP so that you could configure resource-based content delegation or shadow credentials, and so that you can compromise the PKI server. The interesting thing here is that these were the first tools that were using DCOM instead of COM for cross-session activation. And okay, it's not fully cross-session activation because they didn't trigger authentication from a logged-on user, but from the system account. But this was the first time that you were using DCOM to get an authentication via RPC and to relay this to LDAP, which lead to a full domain compromise in the very end. Silver Potato was also published in 2024. also by Andrea, and this tool abused the fact that users that were in the group distributed users or performance log users, that these users were allowed to enable specific COM classes on a remote system to get the incoming authentication from logged on users. So low privileged users, in terms of they are just in one of these two groups, could talk to the DC and say, hey, DC, if there is a domain admin logged on your session 2, please authenticate to me, and I'm going to relay this incoming authentication. So this effectively also lead to full domain compromise. Now you might be wondering, okay, there was quite a nice set of tools, quite a nice set of techniques published. Which of these is still abusable? Which of them is still usable up to date? And what is still possible today is, on the one hand side, to grab netNTLM v1 or netNTLM v2 hashes, depending on the target system's configuration, and to crack them for offline usage later. So this is the local attack vector. When you're logged on, another user's logged in, you can still get their netNTLM v2 hash or v1 and try to crack it. So this is still possible. You can also still relay NTLM or Kerberos authentication when you're logged on a system and an admin is logged on. And you can relay this to a remote system to SMB, to, for example, browse a file system or to create services, so to go for code execution, for example. Or you can relay to ADCS, if this is enabled with web enrollment. You can also relay to MS SQL, for example. But what was fixed, what is not possible anymore, is relaying to LDAP. So if you get an incoming RPC authentication, you cannot relay this to LDAP anymore, which effectively also, or the most severe vulnerabilities which could lead to a full domain compromise from remote, they were actually fixed with this change. So this is actually what Microsoft did here is most important. And on the other hand side, Silver Potato was also fixed. So if you're a member of one of these two groups, you can still not relay authentication from remotely logged on users anymore. So this is also fixed. What's left is these things which are on the top and which are all local, but not remote. And yeah, with Remote Potato, short example on how you would exploit this, how it looks like. So you're logged on a system as the low privileged user. You can, with query user, see that another user is logged in, which is in this case named Hexor. And you can, with this command here, trigger an authentication from the other user. And then you can see that there is an incoming authentication, NTLM type 3 authentication from Hexor. And this is being relayed to, in this case, with Remote Potato to a remote system. The remote system is typically Kali, whatever, with NTLM relay X running. And with NTLM relay, you can then forward this incoming authentication to a remote system, to SMB, to, for example, grab SAM and system credentials, or for code execution or similar. KRB relay can also still be used. So we are, again, the user low priv. We can query the other users. We can use KRB relay to trigger an incoming, this is not the Kerberos relaying yet. This is NTLM, so you can also go for NTLM downgrade with this tool. The nice thing here is that you don't need to have this Kali or another instance of a system there in the same network. You can do this fully with this one tool. You can also use it from a C2 framework, for example. So this is like the main advantage from using KRB relay over Remote Potato. And yeah, if you don't want to grab the netNTLM v1 or v2 hashes, you can also relay to a remote system fully embedded with just this one tool. Then there is a first Kerberos request incoming, a second Kerberos request incoming. The second one is usually relayed to a remote system. And you can also directly dump hashes from a remote system by relaying the incoming authentication. The other tools that were published can not really be used for what they were initially published for. So the only thing that you can do with these tools by now is to use them as an alternative to exploit the ESC8 vulnerability, so the ADCS PKR vulnerability. So this is more or less just an alternative in terms of there's a different trigger. You don't need to use petit potam or printer bug or similar, but instead you can use DCOM to trigger the incoming authentication and to relay this to to the PKI server to get a certificate for domain controller, for example. So this would be the usage for ADCS coerced potato. In this case, you need to have a Kali again as a second system. And if you go for remote KRB relay, then again, you don't need this Kali Linux system. Everything is embedded in this one single assembly. You can also use it from a C2 framework, for example. And you can fully do the ESC8 exploitation from memory, for example, which, from my perspective, the only benefit right now. So this is what's still left and what was published till now. And I was looking for alternatives starting somewhere in the end of last year. And my first thought was, can I find maybe more alternative CLS IDs that can be remotely triggered from a low privileged user to get credentials from a user which is locked on a remote system? This was my initial thought. And on the one hand side, you can audit the permissions in the registry for each and every CLS ID to see who is allowed to use that. Is there maybe some exclusions and so on? But this was too much effort for me somehow, so I was like more in the brute force way, and I was more in the mood like, okay, I'm just going to write a small script which queries all the CLS IDs which are available on my current system, and I'm trying to enable an instance on a remote system with my low privilege user directly to relay to a remote system, to another system via SMB. So I was using remote KRB relay in this case. And I went through all the CLS IDs. This took like 5 hours or 6 hours to run. I was not using parallelization as the others in the previous talk. I was patient, but it turned out I did not get any single incoming authentication for each and every CLS ID, and I did not find anything new here. But I did not want to give up. I was not in the mood like, no. So there must be more. And I was still wondering, okay, till now everyone was focusing on privilege escalation. Till now everyone was focusing on how can you go for an LPE or for relaying from a low privilege user's perspective, but what about administrative privileges? So going away from privilege escalation to maybe credential theft or to lateral movement alternatives. So this was my next thought. And in this case, then at some point, I decided, okay, I'm going to review the permissions. And one tool which you can use for this is Permission Hunter, for example, which is linked here in the bottom. Then you will get a nice Excel sheet in the very end, or a CSV file with all the CLS IDs from the current system. And you can also apply filters on who is allowed to do what with these CLS IDs. And I set a filter up for the run as value as set as interactive user. So this is important. This is what we need to get authentication from a different user. And I configured the launch, or filtered the launch principal to be local administrators or empty. Empty means default permissions, and by default, the administrator is allowed to do that. So if we go for this, then we have a list of potential CLS IDs that can be abused for credential theft or for lateral movement. And it turned out that when you do some small modifications to already existing public tools, namely to Potato Pie and to remote KRB relay, that it's possible with an administrative user to use any of these CLS IDs here to trigger an authentication from a remotely logged on user and to get the NetNTL MV2 hash. So this is 2 pull requests which I made, I don't know, 2 or 3 months ago already to these tools. And with Potato Pie, for example, there was the problem. It was super small thing that when you triggered authentication, the RPC server did not put the incoming authentication hashes to disk and also didn't display it. So I just changed one line, and now it stores the NetNTL MV2 hashes to disk so that you get the incoming authentication. So with a local administrator, you can connect to a remote system, say I want to get the NetNTL MV2 hash from the user logged on in session 2, specify your attacker IP address, and then you will get the incoming hash. So this is quite simple. And with remote KRB relay, there it was the case that it was just supporting Kerberos. It was not supporting NTLM. So in this case, I added the code from the original KRB relay code, more or less copy-paste, put it into remote KRB relay, to also support NTLM downgrade, and in this case, then you can use an administrator to connect to a remote system with this assembly from an already compromised system, and you can get the net NTLM v2 hash from logged on users. But I was still not happy. I was in the mood, okay, we can get the net NTLM v2 hashes, this is cool, okay, but I can also compromise the system. I can also do more. What about relaying? So if we can relay the authentication, we don't need to crack the hash, so we can directly connect to a third system and authenticate there as this user. But it turns out if you try to do this for SMB, which is one of the things that are still left to be possible for doing it locally, then you will get this error message of status bad impersonation level. And this happens for all of the CLS IDs. Almost, as you will see later. One thing that was working, and Andrea Pieri here again helped me and gave me some information because he just released a tool 2 or 3 months ago, which is named KRB Relay X-RPC, which hosts an RPC server and which can relay incoming authentications for the first Kerberos authentication instead of the second. All the other tools do it for the second authentication. This tool does it for the first authentication. And if you combine this tool with the cred marshal trick from James Forshaw, which was published in 2021, so you need to use or to register a host name with this format here, so that the Kerberos SPN is already included and is used. If you combine these the tool with this technique, then you could still relay incoming authentications to a remote SMB system. And you will not get this status bad impersonation error anymore. But as you might know, there was a vulnerability this month, it was fixed now in June, which patched an RCE vulnerability for all the systems, all the Windows systems that have SMB signing disabled, which was quite severe. And the fix for this vulnerability also impacts the fact that we can abuse it here because the cred marshal trick does not work anymore. So you cannot use this formatted host name anymore to trigger authentication to host names with this format. And so you won't get an authentication anymore after this fix is applied. Okay, I was still not happy. And I repeated the same thing with the brute force approach for all the CLS IDs from the current system and tried to relay the connection for all the CLS IDs to see maybe I won't get the status bad impersonation for one of them or for 2 of them or for maybe there is some exclusions. And it turned out that there is one CLS ID which only exists on a client system. So this is the BDE UI launcher class, which is related to BitLocker. And when you use this CLS ID, you can also get the incoming authentication from a remote logged on user on a remote client, and you can relay it to SMB. Because all these fixes, all the stuff that was adjusted for the other classes is not applied to this one CLS ID. So in this case, you can still use this one specific CLS ID to relay incoming authentications to SMB to compromise the system as this user which is already logged in. Where makes this technique sense to be used? So in the very end, there is not many use cases from my perspective, but there is fewer indicators of compromise than if you, from the attacker's perspective, than if you compromise the system, dump Elsas, whatever, to get the credentials. Instead, in this case, you just send one RPC request, you will get the incoming net NTLM v2 hash, you can try to crack it, if the password is crackable, of course, or you can relay it with this one CLS ID to directly impersonate the user on a remote system. So the chances of getting flagged are lower than if you would go the normal way of compromising this remote system, let's say. Relaying to ADCS, for example, would also be possible, but this is only possible if the environment is also vulnerable to ERC8. So if it's vulnerable to ERC8, you will directly get DA. You don't need to actually use this technique. So yeah, this is a little bit pointless. It turned out I did this stuff like in December, January last year and this year, that IBM published a tool in the beginning of April which is doing the same, not the same, but it's even doing it better because they modify existing CLS IDs to make them run as the interactive user because we are admin, we can do this, and they're using CLS IDs that are already available and that let you do SMB authentication or HTTP authentication, so that the SMB or HTTP authentication is being done as the currently logged on user. And if you get an incoming SMB or HTTP authentication, and not RPC, then you can also relay to other services. And you don't have the status bad impersonation issue, because this only applies to incoming RPC authentication and not to SMB authentication. Also, this tool can downgrade to NetNTL MV1 by modifying the remote registry. So it's much better than what I did. Unfortunately for me, on the other hand side, this is super cool research, so you should definitely check this out. Yeah, and there is a tool release where you can fully exploit this whole thing. Yeah, lucky for me on the one hand, unfortunately for me on the one hand side that this was published. At least this is not the only thing I found. So I was happy that the next part is not published yet. So what about getting remote code execution in the context of an already logged on user? So instead of getting just the hash, what about fully impersonating the user with RCE? So our scenario would be the following, that we have one user which is already admin on a workstation or on a server, for example, and that on this workstation there is the domain administrator logged on right now. So this is the scenario. And what would you usually do in such a situation? In a pen test, for example, people would just go there and use tools to remotely dump credentials, like LSA credentials, LSAS, whatever, with NetExec, with LSASI, with all these tools. Just go there, grab the credentials, don't care about detections or stuff like this. The alternative would be to first compromise the system. This is like more the advanced attacker or stealthier approach in terms of, if we have a C2 connection, we are going to compromise the system, we are going to establish a new C2 connection. Then we need to, on the one hand side, impersonate this target user which is currently logged in with token impersonation, or we can inject into one of the processes from this user, or we can go for credential theft once we compromise the system locally, or we can hijack the session, in this case again with COM, which is less documented, but it's still possible. But the thing is, if you go for these techniques, they are well documented, and in many cases this will lead to a lot of indicators of compromise, and it will also lead to alerts, detections, so possibly you might want to look for alternatives. How would you usually compromise the system? How would you initially go for code execution? So for example, via WMI, via WinRM, or via scheduled task execution, or remote service creation. So this is like the most well-known, most used techniques for lateral movement, for code execution, but these are also well documented, and many of the tools that are public, if you just use them out of the box, you will also generate alerts or get detected. Yeah, and then you will see this minion. So the idea was, what if we minimize the IOCs here? What if we just go for one RPC connection on the network level in the very end to trigger something via DCOM? What if we can live in a trusted and in a signed binary, because this is being spawned by our DCOM class? What if we can live directly or execute code directly in the context of a logged on user? Instead of impersonating, instead of stealing credentials, instead of injecting. So this was, in the very end, my goal. This was what I wanted to achieve at this point. And to do so, or to find vulnerabilities, to find new techniques, usually what you need to do is you need to analyze all the classes that are configured as interactive user and to reverse them, to check out their functions and to see what is capable there, what is the input that can be provided, what can be done. And I was analyzing a lot of different classes and did not find anything. At some point, I was checking BDE UI Launcher again, which was the one which had weird exceptions in the first place regarding to relaying. And it turned out that BDE UI Launcher had one function which is called BDE UI process start. And this function takes an U short as an input value, so you can put a string in there. And this was really promising. So in this point I was like, okay, we can start a process and we can influence maybe what is being spawned here as a process. So this might be really interesting for code execution. And I was digging into this specific function, and I saw, it's not highlighted, but there is shell execute xw being used at this point. So indeed, this function spawns a new process. I was wondering, is this really influenced by the input parameter? Can we really define what is being spawned here? And I was in this mood, like this. And as my reversing skills are, I would say, limited, I'm not super good at reversing, I went to a colleague of mine, Sven Rath, so credit to him at this point, and told him, hey, I have a potential new lateral movement technique. Can you take a look? What is happening here? And like after 5 minutes, he was like, yeah, okay, we cannot influence what is being spawned here because it's one of these 4 executables which is being spawned. So BDE unlock.exe, FVE notify.exe, or BAA update.exe, and we can just influence which of these processes being spawned with the first input parameter. If it's 0, then it's the first executable. If it's 1, it's the second, and so on. So yeah, okay. I was not that happy anymore. But then at some point I had another idea, because there was a blog post published like short time before doing this analysis. This is on the next slide. But what do we have here by now? Let's just recap. What can we do? So we can spawn a process, one of these 4 processes which you could see in the image. And we can spawn a process in the context of an already logged on user. We cannot, by now, influence what is being executed, but we are administrator, so we can drop files remotely via SMB, for example, and we can modify the remote registry. So if we can modify the remote registry and something is being spawned, then we have one thing that comes to our rescue, namely COM hijacking. And in COM hijacking, I cannot explain this in depth here now because I don't have the time for it. If you want to know what it's about, check out this blog post here at the bottom. It's super good, super nice explanation, also on how to find COM hijacking. But it turns out that BAA update.exe is searching at HKCU, so for the current user, for different CLS IDs, and these CLS IDs are not set. So we can set them as an attacker. We can set a DLL there, and when this process is spawned, the process will check for this entry, will see our DLL, which we planted on the remote system, and will load it. So we actually get code execution by dropping the DLL and by going for remote COM hijack. BAA update.exe is only vulnerable to COM hijacking when you pass 2 input parameters. The good thing is, with this function, we can pass input parameters, and we can also pass 2 input parameters, and when we do that, it will try to load these CLS IDs. So what is the approach? We're going to plant a DLL on the remote system via $C or admin$, for example. We are going to set a COM hijack for the user which is currently logged in on this remote system via the remote registry. Then we're going to execute BAA update.exe with 2 parameters in the context of the target user. BAA update.exe will load our DLL, execute our malicious code. Afterwards, we're going to clean up. We are going to remove the COM hijack, because if we don't do this, maybe other processes might also all load this DLL, and this might lead to issues. And we're going to clean up the DLL, and voila, we have code execution in the context of a logged on user on a remote system. This will be published, or in proof of concept for doing this whole technique will be published in this link here. And the tool is then called BitlockMove, because this class is related to BitLocker. It's doing something with BitLocker. So we're using something from BitLocker to go get code execution in the context of a logged on user. And yeah, how does it look like? So the tool has 2 modes. First, we can see we are logged on a system, on the system desktop minus whatever, as the user hacker. The user hacker is local administrator on a remote system. This remote system is this one here, desktop minus RESXI lab, and there is the domain admin logged in on this remote system, on this client. And in the first place, we are going for the enum mode. Oops. We are going for the enum mode, so we'll say, I want to enumerate sessions on the remote system, and we can pass the IP address of the remote system. Then we will actually see which sessions do exist on this remote system, and we see there is session 3, which is the DOM ADM. So this is a nice target to go for code execution, because the domain admin is currently logged in. And in the second step, we can go for the attack mode. And in the attack mode, we are going to specify the target system. we're going to specify the path where our malicious DLL is being dropped on the remote system. So we drop it to C Windows temp in this case. We're going to specify the target user, because we need to do this, otherwise the program does not know which user's registry should I modify for the COM hijack. And we can specify a command which should be executed by baa-update.exe. And if we do this, we can see on the remote system, calculator just popped up, because this is being seen by the user because it's happening in the context of this user. So you can also like spawn notepad, and it will spawn interactively on this user which is currently sitting in front of it. Normally, if you go for lateral movement, you don't see the applications because they run as another user or they run as system. In this case, it's happening in the context of the user, so it's also visible if it's a GUI application. And we just executed calculator as proof of concept as the DOM admin user on a client system. There is some things that should be mentioned regarding to BitlockMove. It only works on client systems. Why? Because it's about BitLocker. BitLocker is usually only used on client systems. So you cannot use this POC to execute code on a server system. I actually did not need to go for the Windows 32 APIs that are mentioned on this one slide to set the session ID with this undocumented API, because on a client, usually only one user is logged in. So, and if a second user logs in, the other one is kicked out. So if we have a POC just for clients, we don't need to use the APIs. Code execution will always happen in the context of the user which is logged on in this moment. This POC is potentially OPSEC unsafe because it spawns sub-processes. If you load, for example, shellcode in this DLL, then you will stay in baa-update.exe. You will not spawn a sub-process. So this, using your own DLL instead of the hard-coded one in this POC, is more OPSEC safe. And one thing which should be mentioned here, because we are not just limited to getting code execution on client systems. In this proof of concept, yes. On what I'm publishing here, yes. But if you go for all these other CLS IDs that are configured to run as the interactive user, and you just call co-create instance for them on a remote system, this in many cases already spawns a process as the interactive user. And if one of these executables is vulnerable to a COM hijack, then you can also go for code execution on server systems. And one way to, for example, on how to enumerate other CLS IDs that configure to be run as the interactive user would be to use oleview.net from James Forshaw with get-com class interactive user, and then you see which CLS IDs are configured to be run as interactive user, and you see which executable or DLL is being used here. So it might be the case that when you execute this CLS ID here from remote, that the browser broker.exe is being spawned, and if this is vulnerable to COM hijacking, you can set the remote COM hijack, and you can also get code execution on server systems. It turns out this works for a lot of these CLS IDs, but this will not be published. So if someone wants to do this, you need to do a little bit of fiddling around and adjust the proof of concept, and then you can also execute code on server systems. I need to give credit to certain people here, James Forshaw in the first place, because he published all the groundwork for everything. So what he published is this is crazy and amazing, but this is, without his publications, nothing else would exist actually. Then Andrea Pierini, because he published with Antonio Cocomazzi together Remote Potato and also Silver Potato later. And he also helped me with KRB Relay X RPC at one point, and gave me some hints here and there. Then Michael, don't know how to spell that, CH Milo, because he published Remote KRB Relay, and this is what I modified in the first place for credential theft. And what is super nice too from my perspective, Cube, who published KRB Relay. I don't know his real name, but so there's just the handle right now. And my colleague Sven Rath, because he helped me in the reversing process. Going one step back, so we said, this is fixed, right? We said the cred marshal trick is not possible anymore because there was a fix so that you cannot use the cred marshal trick anymore for relaying purposes. It turns out, if you go for BitLocker CLS ID from BDE UI Launcher, this still works again. So this one CLS ID is not influenced by all these patches, but it can still be used to relay incoming connections, also for when the cred marshal trick is being used. So all these patches don't influence this CLS ID. This doesn't mean it's a bypass for this CVE, because you cannot create an instance of this class with a low-privileged user. You can only do this with an administrator, so you can compromise the system anyway. This is not RCE. But it's a fun fact, because this CLS ID is different to the others. Why? I was too lazy to spend much time on it. I found it out and was like, okay, it's the case. Fun fact, but it's not like super important from my perspective. A few words about detection maybe. So from the proof of concept, which will be published after this talk, this DLL, which is hard-coded and which is always dropped on the remote system, this has obvious IOCs. So if there is any AV EDR vendors checking this out here, check out the strings from the DLLs. There are strings that you will not see in any other DLL anywhere, and it's very easy to flag this. On the other hand side, if you want to go for behavior-based detection, you can check for a COM hijack for the specific CLS ID which is being used in this proof of concept. Or you can check for BAA update.exe, loading unexpected DLLs from an attacker-defined path, because usually it should not load DLLs from C Windows 10, for example, or from other strange paths. And the third thing is it's spawning a sub-process with the proof of concept, always. Normally, BAA update.exe is not spawning sub-process. So this is pretty easy to detect with a behavior-based detection. That's it. Thank you for your attention. And is there questions?
Yes, we have quite some time, so if you have questions, feel free to ask.
I was so fast. Then I talked too fast.
Earlier lunch is also okay, so. No questions?
So to override in registry, do you need a remote registry to be enabled on the client?
Yes, but the proof of concept is enabling the remote registry if it's not enabled. So
yeah.
it makes sure that the COM hijack can be set, because we are admins, so we can also enable the remote registry. If it's not enabled, the proof of concept will enable it, and so that the COM hijack can be set.
Nice.
Hi, thanks for your talk. If I have to drop a DLL anyway, and if I have to write to the registry anyway, why do I not just replace the DLL for the class ID I'm going to trigger instead of using this long way with BAA update?
Because usually, of course, you can set a remote COM hijack. You can also set a remote COM hijack for any executable where you know that this loads a specific CLS ID. You can set a remote COM hijack for, I don't know, Chrome, and every time when the user opens Chrome, your DLL will be loaded. But you cannot influence if the user opens Chrome. So my goal was to know the code is directly being loaded and to influence this code execution and not to wait for the user to open certain processes that are vulnerable to COM hijacking, and I didn't want to wait. But instead I wanted to execute, to have an execute primitive, and the execute primitive should be decom. This was my goal, because it's less likely flagged than going for other. If I'm just executing BAA update.exe via WMI, this is more likely being flagged than by sending one RPC request.
But BAA update is run by BRD tralala DLL, which is triggered by decom, right? So you could just replace the first DLL that would then run BAA update.
I could replace the first? Don't fully understand.
BAA update is executed by a DLL, by decom object, right?
It's not by, no. The process which spawns BAA update.exe is bdeuisrv.exe.
Yeah.
And this is the executable which is being spawned with this COM class.
You know, and this COM class, if you replace that one, you could directly execute your code.
No, because bdeuisrv.exe is not vulnerable to COM hijacking.
But if I replace the link from the class ID to BDIUI DLL to BDIUI DLL custom, then
Yeah,
it
you
would
can do
directly
this.
run
You can,
my
yeah,
code.
but yeah. Let me think about it. I don't think that BDE-UI srv.exe is calling BAA-update.exe by checking the registry. So you cannot modify in CLSID where BAA-update is being spawned to another executable. This is not working.
No, I cannot replace the BAA update that is. I cannot replace the command line that's actually BAA update exe, but I can replace the link from the class ID of BDUI DLL, pointing not to BDUI DLL but to attacker DLL.
I don't fully understand what you.
You have the class ID, you have the class ID of BDUI DLL. So there's a registry key with the class ID saying go to BDUI DLL. And if I overwrite this entry, it would instead directly execute attacker DLL.
Yeah, but this is what the proof of concept is doing. So what
But
would you
But
recommend
it
here?
uses a long way. It first executes BDUI DLL, then it executes BA update DLL, and then it loads attacker DLL. Why not just use attacker DLL in the beginning?
This is not working.
Why?
Because what is being, if you execute this specific class, and this specific class has an app ID, it has an CLS ID, and at some point, yes, there is specified BDE UI srv.exe is being executed when you call this class. Of course, you could modify this HKLM entry, which contains this executable. Normally you cannot, so you first need to modify the permissions for this entry, because normally you cannot modify HKLM entries. You need to first modify the permissions. After doing that, you could also replace the executable, yes, but I would personally just not prefer to execute an unsigned executable defined by the attacker, because unsigned executables are more prone to detections again. So it's detection-wise more OPSEC safe to get an DLL to load into a trusted signed process.
Okay, thanks.
So this is why I prefer DLL side loading in variant or com hijack here, instead of spawning an unsigned executable from the attacker.
Hi, so if I was looking at this communication at the network layer using Wireshark, let's say, I'd see SMB communication, right, for dropping that DLL and for remote registry. Then I would see port 135 for the DCOM activation.
Yeah.
Would there be any other port involved, like the dynamic RPC, or is that it, just these two port numbers?
So WMI is being used in the proof of concept to start the remote registry, because this was just easy. I mean, it can be changed, but so WMI is also being used. I think this should be 139 for WMI.
It's actually random by
Or is it
by
also? Yeah,
default.
okay.
Yeah.
So yeah, so but in the variant, the registry is started via WMI, then the remote registry is modified. This, I'm not 100% sure, didn't analyze it in Wireshark, but I think this is also RPC.
Mm-hmm. Yeah.
And then SMB for dropping the DLL, and then RPC again for the execute primitive.
Mm-hmm. Great, thanks.
Yeah.
Hi. First, thank you. I'm really hoping to get to use that soon. When you said like BitLocker only on clients, first thought would be like, what about terminal servers with a desktop experience installed? Which could be a
Do
really
they not
treasure
have
trove.
BitLocker?
No BitLocker then with
If BitLocker is not implemented on the system, you will not find the CLS ID, and the proof of concept will not work.
Okay, great. Thanks.
So it's quite simple. But on the other hand side, and this is, I'm not like publishing it, because once you publish something, this is like, I could publish like 50 proof of concept with different executables here. I'm instead just publishing one and tell the people who are aware on how to code and on how to modify this, that you can also spawn a lot of other processes and execute code in their context. So in the very end, this technique is not restricted to BitLocker only. Only this proof of concept is.
Okay, other questions? Okay, thank you, Fabian.
You're welcome.